Next problem. Autocorrelation function of a Poisson increment process is given by r of tau, which is equal to lambda square if tau is greater than modulus tau is greater than t. Lambda square plus lambda by t into 1 minus modulus tau by t modulus tau is less than or equal to t. Prove that the spectral density is s omega, which is equal to 2 pi lambda square del omega plus 4 lambda sine square omega t by 2 t square plus t square into omega square. So given r of tau autocorrelation is equal to lambda square, otherwise lambda square plus lambda by t into 1 minus modulus tau by t if tau lies between minus t to plus t. So I am taking modulus tau less than or equal to t means minus t to plus t, tau lies between. Then the top one is otherwise, right? That is equation number 1. We know spectral density function s omega, which is equal to Fourier transform of autocorrelation r of tau, that is equal to minus infinite to plus infinite r of tau e power I omega tau d tau, which is equal to minus infinite to minus t lambda square e power minus I omega tau d tau, right? So what is given in minus t to plus t, tau lies between minus t to plus t, r value is nothing but lambda square plus lambda by t into 1 minus modulus tau by t. Lambda square otherwise means in other area r value is lambda square. So I am splitting the integral into 3. First is minus infinite to minus t. In that it is not lies between minus t to plus t, so we are taking lambda square, r value is lambda square e power minus I omega tau d tau, plus next is minus t to plus t. In that particular integral r value is given lambda square plus lambda by t into 1 minus modulus tau by t into e power I omega tau d tau. Then last one is plus t to infinite. So lambda square e power minus I omega tau d tau. So using 1. So that is equal to minus infinite to minus t lambda square e power I omega tau d tau plus minus t to plus t lambda square e power minus I omega tau d tau plus t to infinite lambda square e power minus I omega tau d tau plus integral minus t to plus t lambda t into 1 minus mod tau by t into e power minus I omega tau d tau. What happened in the second integral? The top second integral there is two terms. There are two terms, lambda square plus lambda t into 1 minus mod tau by t. So I am splitting that integral, that is minus t to plus t in that limit. So I am splitting the integral into two. First one is minus t to plus t lambda square e power minus I omega tau d tau. Second one is minus t to plus t lambda by t into 1 minus mod tau by t into e power minus I omega tau d tau. So that is what we get 4 integral in down, right? That is equal to minus infinite to plus infinite lambda square e power minus I omega tau d tau. What happened? So see, first 3 integrals all are lambda square. Integrand is lambda square e power minus I omega tau d tau, right? See the limit minus infinite to minus t, continuous limit, t minus t to plus t, then t to infinite. So I am grouping all those things. So minus infinite to plus infinite lambda square e power minus I omega tau d tau. So I grouped all the 3 integrals into one because the limit is continuous and integrand are same. So that is why. So that becomes integral minus infinite to plus infinite lambda square e power minus I omega tau d tau. Then the remaining integral plus minus t to plus t lambda by t 1 minus mod tau by t e power minus I omega tau d tau. So lambda square is constant. I am taking a lambda square outside from the integral. So you will get minus infinite to plus infinite e power minus I omega tau d tau plus integral minus t to plus t lambda by t 1 minus mod tau by t cos omega tau plus I sin omega tau d tau, because e power minus I omega tau is equal to cos minus I sin, de Moivre's theorem. So which is equal to lambda square. We know the value of integral minus infinite to plus infinite e power minus I omega tau d tau is nothing but 2 pi del omega, right? Delta function, direct delta function. From the definition of direct delta function, it is del omega plus integral minus t to plus t lambda t into 1 minus mod tau by t cos omega tau d tau plus I minus t to plus t lambda by t 1 to 1 minus mod tau by t sin omega tau d tau, that is equation number 2, that is equal to, so first integrand is an even function, right, and the second integrand is an odd function, correct, because of first integrand modulus tau, so modulus tau is one term 1 minus modulus tau by t something, right. So modulus tau, whenever you are putting minus tau, you will get the same one, and cos omega is an even function, product of even function is an even function, so first integrand even function. The second one 1 minus modulus tau by t into sin omega tau, so 1 minus modulus tau by t is an even function, sin omega is an odd function, product of even and odd, you will get an odd function, so totally second integrand is an odd function. Then using the properties of definite integral, so you will get s omega which is equal to lambda square 2 pi del omega plus first is an even function integrand, so the limit minus t to plus t becomes 2 into integral 0 to t lambda by t 1 minus mod tau by t into cos omega tau d tau plus the second integrand minus t to plus t integrand is an odd function, so total value is 0 by the definition of properties of definite integral. So this is equal to 2 pi lambda square del omega plus 2 lambda by t is a constant, you take it outside, integral 0 to t 1 minus 0 to t is a positive interval, so mod tau is tau only, so 1 minus tau by t into cos omega tau can be written as cos omega tau d tau can be written as derivative of sin omega tau by omega. So now we are going to use uv, so 2 pi lambda square, so u is nothing but 1 minus nothing but sin omega tau by t. So first uv, u omega tau by omega minus integral v du, integral 0 to t, v is nothing but sin omega tau by omega into dv, derivative of u, derivative of u, that is equal to 1 minus tau by t, right. So now this is equal to 2 pi lambda square del omega plus 2 lambda by t. We are substituting the upper limit, instead of tau you are putting t, small t, 1 minus t by t sin omega t by omega, we are replacing tau by t, and then lower limit, so we are going to replace tau by 0, so 1 minus 0, right, 0 by something 0, sin 0 0 into 0 minus integral 0 to t sin omega tau by omega, this is derivative of 1 0, so derivative of minus tau by t which is equal to minus of d tau by t, right, that is equal to 2 pi lambda square del omega plus 2 lambda by t. So completely total term vanishes because 1 minus t by t 1 minus 1 0, and then second term also 0, so 0 plus t 1 by t is constant with respect to that integral, omega is also constant, so in the denominator you are having t omega, take it outside, 1 by t omega 0 to t sin omega tau d tau is equal to 2 pi lambda square del omega plus 2 lambda t square omega, so integral sin omega tau which is nothing but minus cos omega tau by omega, lower limit 0, upper limit t, so which is equal to 2 pi lambda square del omega minus 2 lambda by t square omega square cos omega tau, instead of tau we are putting the upper limit t, minus instead of tau we are putting 0 cos 0, that is equal to 2 pi lambda square del omega plus 2 lambda by t square omega square 1 minus cos omega t, that is equal to 2 pi lambda square del omega plus 2 lambda by t square omega square plus 2 sin square omega t by 2. We know 1 minus cos a which is equal to 2 sin square a by 2. Here a is equal to omega t. Therefore, S omega is equal to 2 pi lambda square del omega plus 4 lambda by t square omega square sin square omega t by 2. That's all. Thanks. We'll see you in the next video.